Welcome to qnawire.
So here, if there's no friction, we can say that the velocity of the block would be equal to the velocity of the cord, which would be equal to the angular velocity of the cord times r. We can say that this is assuming essentially that the cord unrolls from the cylinder without slipping. And we're going to take the zero position of the gravitational potential energy to be the bottom of the motion of the block. So we can say that because the cylinder, however, does not move vertically, we do not have to consider its gravitational potential energy. We only have to use the law of conservation of energy initially and then equate it to the final kinetic energy. So we can say that E initial would be equal to E final, and we can say that the potential energy initial would be equal to the kinetic energy final, and this would be equal to the kinetic energy of the block plus the kinetic energy of the cylinder. So we can say mgh is equaling 1/2 mv squared plus 1/2 I omega squared. And we can say mgd of theta equals 1/2 mv squared plus 1/2 times 1/2 capital M r squared to the mass of the cylinder. This would simply be the formula for the moment of inertia for a cylinder, and then multiplied by v squared over r squared. If the block isn't slipping, we can make this assumption. And so we can say that v is simply going to be equal to the square root of 2mg d sine of theta divided by m plus 1/2 m. And let's solve. So v would be equal to the square root of 2 times 3.0 kilograms multiplied by 9.80 meters per second squared. This would be multiplied by 1.80 meters multiplied by sine of 27 degrees. This would all be divided by 19.5 kilograms. And we find that the velocity is going to be equal to 1.57 meters per second. That would be your answer for part A. Now, for part B, however, let's draw the diagram. We have we can say that this would be the block. Perpendicular to the surface of contact would be force normal sub 1. Going straight down would, of course, be mg. Opposite to the direction of motion would be force friction sub 1. This would also be force tension acting. And then for the second, we can say going up would be force normal sub 2. Tangential to the surface, we have force tension. We would say counterclockwise would be the torque of friction sub 2. And then going straight down would, of course, be capital mg, the weight. So we could say that here, we're going to say that the coefficient of friction, mu, before we go ahead, we can say that in order for the block to move down the plane from rest, we know that the force tension must be less than mg. We also know that mg must be less than 0.1 capital mg due to the difference in masses. So we can say that then force tension would be less than 0.1 mg. When finding the net vertical and horizontal forces on the cylinder, we can ignore the force tension, and we're simply going to say that we know that we're at least going to make less than a if we make these assumptions. So we can finally assume that also force of friction sub 2 equals mu f of n sub 2, and this would equal mu m sub g. So at this point, we can apply the sum of forces. We know that the cord unrolls without slipping, so cord unrolls without slipping. So we can say the sum of forces in the y direction would equal force normal minus mg cosine of theta. This would equal 0. So we can say force normal would be equal to mg cosine of theta. We could say that the sum of forces in the x direction would then be equal to mg sine of theta minus force tension minus force of friction sub 1. And so this will equal mg sine of theta minus force tension minus mu mg cosine of theta. This is equaling ma. Sub 1. We can say that the sum of torques is going to be equal to force tension R minus the frictional torque sub 2. This would equal force tension sub R minus the coefficient of friction times F of n sub 2 times R. This would equal force tension sub R minus mu mgr, and this is going to be equal to the moment of inertia times the angular acceleration. We can say that the net torque is also equal to the moment of inertia times the tangential acceleration divided by the radius, and then this would be equal to simply 1/2 mr a, the tangential acceleration. So we can say that the force tension minus the coefficient of friction times mg would be equal to 1/2 times ma. We're going to add the x equation to the torque equation. So we can say that's mg sine of theta minus force tension minus coefficient of kinetic friction mg cosine of theta. This would equal ma. Force tension minus the coefficient of friction times mg would equal 1/2 ma. Again, 1/2 ma. Again, we can say mg sine of theta minus the coefficient of friction times mg minus the coefficient of friction times mg cosine of theta would be equal to ma plus 1/2 ma. So we're basically just combining those two equations for the x equation. We're combining the torque equation for the and the x equation, and then solve for the acceleration. So the acceleration would simply be equal to g times the mass times sine of theta minus the coefficient of kinetic friction times cosine of theta minus the coefficient of friction times m divided by the mass on the incline plus 1/2 capital M. So we can say there are two versions of the book, actually. So some versions of the book will have mu equaling 0.055. Some versions of the book will have mu equaling 0.035. We'll calculate for both. So the acceleration would be equal to g times 3.0 kilograms times sine of 27 degrees minus 0.055. So this is when the coefficient of friction equals 0.055 times cosine of 27 degrees minus 0.055 times 33 kilograms. And then this will all be divided by 19.5 kilograms. This is A will equal negative 0.302 meters per second squared. This is equaling wherein mu equals 0.055. So when mu equals 0.055, the acceleration is negative 0.302 meters per second. However, the object cannot accelerate up the plane from rest. So here, the conclusion is that the object will not move with a coefficient of 0.055 because you cannot accelerate up from rest. So here we can say that block will not move because you cannot accelerate up the incline from rest. So let's try mu equaling 0.035. So acceleration would then be equal to, again, g, the acceleration due to gravity on Earth, times 3.0 kilograms times sine of 27 degrees minus 0.035 cosine of 27 degrees minus 0.035 times 33 kilograms, all divided by 19.5 kilograms. And we find that the acceleration is 0.057 meters per second. So it being positive means that here it will move. So the block will move, and then we'll actually use this in order to find our final velocity. So we can say velocity final squared equals velocity initial squared plus 2 times the acceleration times delta x. Velocity initial we know is going to be 0 because it's starting from rest. And so our final velocity would be equal to the square root of 2 times a delta x. This would equal 2 times 0.057 meters per second squared multiplied by 1.80 meters. And we find that velocity final here would be 0.45 meters per second. So this would be our final answer for the final velocity. That is the end of the solution. Thank you for watching.